Have you ever looked up in the night sky and wondered about the mysterious blue giant known as Neptune? Despite being a major planet, 4 times the size of Earth and 4.5 billion kilometers away, it's often overlooked. But recent surprising changes in its atmosphere have scientists scratching their heads. Join us as we dive into the secrets of this celestial enigma and uncover what's really happening on Neptune. Neptune, our solar system's last known major planet, was discovered in 1846 by German astronomer Johann Galle. The discovery was a result of mathematical predictions made by French mathematician Urbain Verrier, who noticed that Uranus deviated from its predicted orbit. Verrier calculated the position of a yet unknown celestial body that was causing the deviation, and Galle finally discovered Neptune using a telescope on September 23, 1846. This discovery confirmed the existence of an undiscovered planet in our solar system and the accuracy of the mathematical predictions. Neptune is the 8th planet from the Sun, with a diameter 4 times that of Earth. It is also 4.5 billion kilometers away from us, making it the most distant planet known to us from the Sun. Despite its size and distance from Earth, Neptune receives little attention in comparison to other planets in our solar system. Planets such as Jupiter and Mars receive more attention from scientists and the public, and even Saturn has had a spacecraft orbit it for 13 years. Recently, scientists have started to pay more attention to Neptune. The possibility of rings around Neptune has been a subject of debate among scientists for many years. In 2016, the Hubble Space Telescope detected a possible ring system around the planet, but it's unclear whether these rings are permanent or temporary. The rings, if they are indeed present, are thought to be made up of small particles of ice and dust, similar to the rings of Saturn. The rings are also thought to be relatively young, possibly formed by the collision of small moons or comets with Neptune. The detection of these possible rings was made using observations of the planet's occultation, which is when the planet passed in front of a distant star. The occultation caused the star's light to be blocked, revealing the presence of a ring system. The rings were detected in the infrared spectrum, which suggests that they are composed of small particles of ice and dust. Another point of interest is Neptune's distinctive blue appearance. The planet's atmosphere contains methane, which absorbs the red colors of incoming sunlight and reflects the blues and greens, giving the planet its distinct color. For many years, scientists have been puzzled by Neptune's blue color, and it's still unclear how the planet's atmosphere can give it such a distinct color. According to recent theory, the blue color is caused by methane in the atmosphere, absorbing red light and reflecting blue and green light to our eyes. This process is known as Rayleigh scattering, and it's responsible for the blue color of the Earth's sky. Neptune's atmosphere is primarily made of hydrogen and helium, with a trace of methane. Methane is a hydrocarbon gas with 1 carbon atom and 4 hydrogen atoms. The atmosphere's methane absorbs red light while reflecting blue and green light, giving the planet its blue color. The vibrations of the methane molecule caused the absorption of red light, which causes it to be absorbed and re-emitted at a different wavelength. This process is analogous to how chlorophyll in plants absorbs red and blue light while reflecting green light. Scientists have recently observed dramatic changes in Neptune's atmosphere, raising concerns about the potential causes and effects on the solar system. The formation of new storms, such as Neptune's little spot, and the disappearance of previously observed storms, such as the Great Dark Spot, are examples of these changes. The Great Dark Spot and Neptune's little spot are 2 of Neptune's most intriguing and mysterious features. These large, dark circular features are thought to be massive storm systems, comparable in size and appearance to Jupiter's Great Red Spot. The Great Dark Spot was discovered in 1989 by the Voyager 2 spacecraft, while Neptune's little spot was discovered in 2018 by the Hubble Space Telescope. The Great Dark Spot was a high-pressure system the size of the Earth that was located in the planet's southern hemisphere. It appeared as a dark circular feature in the image taken by the Voyager 2. Scientists believe it was caused by the planet's strong winds and high-pressure systems. It was also thought that the storm was caused by a high concentration of methane in the atmosphere, which absorbs red light and reflects blue light, making the storm appear dark in telescope images. The Great Dark Spot was a dynamic feature that changed shape and moved around the planet. The spot, however, vanished in the 1990s, and its disappearance remains a mystery. Scientists speculate that the spot may have dissipated due to changes in the planet's weather patterns, or that it was an episodic feature, similar to Jupiter's Great Red Spot. Neptune's Little Spot, also known as New Great Dark Spot, is a massive storm system located in the southern hemisphere of the planet, similar to the Great Dark Spot. It is roughly the size of the United States, and it's the second largest storm system. The storm is thought to be caused by a high-pressure system similar to Jupiter's Great Red Spot. This storm is also believed to be caused by a high concentration of methane in the atmosphere, which, again, absorbs red light and reflects blue light, making the storm appear dark in telescope images. The storm system is also dynamic, as evidenced by its ability to change shape and move around the planet. Scientists believe it is again caused by the planet's strong winds and high-pressure systems. Extreme weather conditions on the planet are one possible cause of these changes. Neptune has the solar system's strongest winds, reaching speeds up to 2,100 kilometers per hour. These winds can stir up methane particles and thin out the haze layer, changing the color of the planet and causing new storms to form. Another possible explanation is the presence of a vast ocean beneath the planet's atmosphere. Scientists believe that this ocean, which is made up of water, ammonia, and methane, can change the dynamics of the atmosphere and cause new storms to form. The ocean is believed to be heated by the planet's internal heat, which also can cause storms to form on the surface. Changes in Neptune's atmosphere can impact the planet's climate and weather patterns. The formation of new storms can alter the distribution of heat around the planet, causing temperature and weather patterns to change. Changes in the atmosphere can also have an impact on the planet's magnetosphere, which is the region around the planet where charged particles are influenced by the magnetic field. The study of Neptune's atmosphere and changes are intertwined with research on Uranus and the hypothetical Planet 9. Uranus and Neptune are referred to as ice giants because of their size and composition, which are similar to Jupiter and Saturn but are mostly made of icy materials. The study of these two planets can provide important insights into the dynamics of planetary atmospheres, as well as the processes that drive climate and weather on these types of planets. There has been renewed interest in studying Uranus in recent years, with several proposals for NASA to send a probe to the planet in the future. The last time a spacecraft visited Uranus was in 1986, when the Voyager 2 spacecraft flew by the planet. Sending a probe to Uranus would allow scientists to better understand the planet's atmosphere and its weather patterns, as well as look for signs of life. This new information can be used to better understand Uranus's climate, internal structure, geology, magnetic field, as well as its ring and moon systems. The search for Planet 9 is another area of study that is closely related to the study of Neptune and Uranus. Planet 9 is a speculative planet thought to orbit the Sun beyond Neptune. The existence of this planet is based on observations of distant celestial objects' orbits, such as Kuiper belt objects, which indicate the presence of a massive planet influencing their orbit. This hypothetical planet is thought to have a mass 10 times that of Earth, and an orbital period of 20 to 30,000 years. The discovery of this planet would have far-reaching implications for our understanding of the solar system and planetary orbit dynamics. We hope you enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.